to us of quantum physics. Now, what's quantum physics? I'm not going to spend a lot of time on it, but essentially it's a variety of physics that deals with subatomic, submolecular, the very tiniest particles that are out there, down at the very, protons, neutrons, electrons, quarks, charm quarks, neutrinos, croutons, protons, etc. See, I threw in the croutons to see if you're paying attention. And all of these move in a fashion that at times seems counterintuitive to the way we think the world works. Just as one example, there's a subatomic particle called the neutrino, which is able to travel through a light year of lead instantly, just like that. Now, that's supposed to be impossible. That's supposed to be contrary to all known laws of physics. But it winks out of existence in our universe, and microseconds later, it winks back into existence somewhere else. Very strange particle. And it's this kind of spooky stuff that is what we're dealing with here tonight. Now, these weapons are beyond Star Trek. Now, I'm using Star Trek because it's very well known. I'm sure probably most of you have at least seen one episode of Star Trek. I don't care how sanctified you are. And, the little spaceships flying through the sky, like that with lasers or phasers or whatever they are. That stuff is like buggy whips. And this stuff is like a Maserati that we're talking about tonight. So this stuff is so advanced that even most science fiction writers haven't used it as, and it certainly, to my knowledge, has never appeared in any science fiction film. Okay, what are energetics? Well, we all kind of understand electromagnetic energy. It's what runs virtually everything we have. I mean, from our homes, our cars, whatever. And electromagnetic energy travels in transverse waves. And everybody understands that, no contest. However, scalar waves are of a different variety. They are longitudinal in nature. That means they go in the opposite direction. And in scalar mode, electromagnetic energy can be changed into gravitational energy, and vice versa. Now, that's a little hard to understand, and I want to apologize. The next few of these slides are going to be a little bit dense in terms of physics, but I'll try and get through them and make it as easy as you can. Gravitation is not readily understood. We more or less understand electromagnetism, but we know gravity works. I mean, we know if we take an apple and drop it, it'll fall to the earth. But why does that happen? Well, Einstein, many years ago, came up with a postulation. He said the entire Earth, or the entire universe for that matter, is one big sphere. It's like a giant bubble that's hollow inside. And that when you have a large mass, like a planet or a star or something of that nature, in space, it causes a dimple in the fabric of space. It causes a little divot, if you will, like that, those of you that are golfers. And that is called a gravity well. And so if something comes along, like a comet or whatever, and it hits the edge of this gravity well, it starts going into this circular motion, just like in your bathroom sink. If you put a marble in your bathroom sink, it'll go around and around and around, and eventually it'll come right to the drain. That's what happens with a meteor. It will go around and around the Earth and eventually hit the Earth's atmosphere and hopefully burn up. So that was Einstein's explanation for gravity. And the way we know it's true is some years after that, they took a picture of a solar eclipse. Now that's where you have the moon coming between us and the sun. Okay, so you see this black circle with these prominences, the solar corona flaring up around it. And what they noticed was something really astonishing. They could look at that black disk that was inside the sun, or appeared to be. You know what they saw? They saw a star inside of that black disk. And that told them that Einstein was right. You know why? Because what had happened is that the starlight was coming into the sun's gravity well, and it bent around the sun and came out the other side. So to us, on Earth, it appeared as though the line went straight through the sun, and we were actually seeing through the sun. Actually, the sun was able to bend light. Now that sounds really bizarre to people that live on the Earth in the real world, you know. But if you're an astrophysicist, that's common knowledge nowadays. So Think of it as something that is very mysterious, that can even bend the very fabric of light. Now, this energy exchange that we're talking about between electromagnetic and electrogravitic energy can be localized or aimed to a specific location. In other words, you can target things with it. Scalar waves don't exist in our normal world normally. They are in the vacuum of space. They exist in the dimension of time. And since the vacuum of space exists everywhere, scalar waves can draw on vast amounts of energy. This is called energy from the vacuum, or zero-point energy. This energy can be transmitted faster, literally, than the speed of light. Now, Einstein taught that the speed of light is the speed limit of the universe. And what it is roughly 186,000 miles a second. Or, if you prefer, 670 million miles an hour. So that's a whole lot faster than you can go in your car, I'm sure. And the interesting thing is that if you were to say the word light, in the time it takes to say the word light, light can travel around the world 7 times. That's how fast it is. So it's very, very fast. But Einstein taught that you can't go faster than that. As we will see tonight, Einstein has been proven wrong in several ways. The way these scalar waves travel faster than light is that they go through hyperspace and go around regular space. Now, you'll notice here in this chart, you have this large white sphere. That is the universe, okay? And you see the red arrow, it's pointing to the surface of that big white sphere. That is space, just like if you think of a basketball. You think of the rubber or whatever is around the basketball, that's the space. That's where we live. That's where the entire universe lives, is in this thin membrane around this giant nothing. Okay? This is what Einstein postulated, and everything so far has proven him right. Now, the question you need to ask yourself, if the surface, just the line around the surface of that sphere is space, what's inside of it? What's outside of it? Unspace. Now, this might bake your noodle a little, but listen. How long does it take to travel through unspace? No time at all. You can travel anywhere in the universe in a second if you travel through unspace, or as scientists prefer to call it, either subspace or hyperspace. Yeah, these words are not science fiction anymore, even though you hear them used in various science fiction movies, but actually this is a reality. They've determined this is true. So here's how this works. You notice down at the bottom of your screen, there is a scalar transmitter represented by point A. Let's say that's the Crab Nebula, which is millions of light years from Earth, and there's some nasty aliens on that nebula, and they are mad at that destroyer that's up in the upper right-hand corner of the screen that's floating somewhere in the Atlantic. They have scalar weapons. They fire their weapon instantly. It winks out of existence. It follows the trajectory of that red line on the screen, goes through hyperspace in about a second or less, and emerges right on top of that destroyer as a globe of light that then detonates with the near force of a nuclear explosion and blows the destroyer to kingdom come. Now let's bring this down to Earth. Suppose instead of that big white circle being the universe, it's planet Earth. And point A is Moscow. And they, for whatever reason, decide they're going to destroy that battleship that's in the Atlantic Ocean. And so they fire their scalar transmitter. In a second or so or less, the same thing happens. There's no way of seeing this coming. Understand, there is no incoming fire. It's not like a cruise missile or something like that. It's just there all of a sudden. The next second, it detonates and the thing sinks just with all hands on board. This is the nature of this weapon. Now, these next 2 slides are probably the worst, so bear with me. In the scalar model, time, which Einstein said is the 4th dimension, is actually compressed energy. So imagine being able to use both time and gravity as energy. It is energy which is compressed by exactly the same factor by which matter is considered compressed energy.